What is the soil food web? To understand the soil food web, let's start with the term food web. We all know about the food chain, the animal kingdom on top of which are us humans, right? Well, if we look a little closer, we can see that some members of the food chain don't just eat one thing. That goes for humans too. So the reality is more like a web than a chain. This is the food web. There happens to be a food web in the soil too. This is the living part of the soil made up of insects, earthworms, and much smaller microscopic creatures such as fungi and bacteria. Dr. Elaine Ingham has pioneered research into the microorganisms in the soil over the last 4 decades and has worked with a team of research scientists to understand how they interact with each other and with plants. The soil food web can be thought of as the soil biome. Just as humans have a gut biome responsible for digesting our foods, so too the soil has a biome, which breaks down organic matter and releases nutrients in plant-available form. This is how nature has been feeding plants for billions of years. The major groups that make up the soil food web are bacteria, fungi, protozoa, and nematodes. When in balance, these different groups interact with each other and with plants to create abundant ecosystems such as the great forests of the world. Have you ever wondered how forests can be the most productive ecosystems in the world without the need for any fertilizers or pesticides? The answer lies in soil biology. With a healthy biome, the soil can provide plants with all the nutrients they need, and with a number of other benefits, such as protection from pests and diseases, protection from drought and from flooding. The soil food web is, essentially, nature's operating system. Unfortunately, we humans have disturbed the soil food web in almost all of the soils that we manage, causing it to become unbalanced. As a result, the plants we grow struggle. Plowing is the major cause of the problem, as it destroys the larger microorganisms, such as fungi and protozoa, leaving the soil food web out of balance. This results in a system breakdown. Nutrients are no longer made available to plants, and protection from diseases is compromised. Before the Industrial Revolution, humans would plow using oxen or a bull, which provided around 3 or 4 horsepower. Modern tractors can yield 400 horsepower or more. So far more damage is done to the soil biome by modern machinery. The use of chemicals has compounded the problem. The good news is that we can restore the soil food web to most soils within just a few months. This results in a number of benefits, both for farmers and for the environment. With a balanced soil food web in place, farmers need not use fertilizers at all. They don't need to use pesticides either, as nature's operating system protects plants from attack. Herbicides, used to kill weeds, are not required either, as weeds only thrive in conditions where the food web is out of balance. Restoring the soil food web means farmers save money on chemical inputs across the board. It also means that their yields increase dramatically. In some cases, farmers working with Dr. Elaine Ingham have seen yields increase by over 200%. This is because the soil food web provides plants access to a constant flow of nutrients from soil organic matter and from the soil particles themselves. That's right, sand particles contain nutrients, and guess what? Fungi and bacteria can harvest those nutrients. They then make these available to the plant in a process that the plant actually controls. This means that plants get access to the type of nutrients they need precisely when they need them. That's how you maximize yields and optimize profits. For the environment, there is a whole host of benefits of having a balanced soil food web. Humanity is facing a number of existential threats. Let's take a look at how some of these are related to the soil. The most obvious one is soil erosion. The United Nations Food and Agriculture Organization has estimated that we only have around 60 years left before all the world's topsoil is depleted. Other estimates are as low as 30 years. The soil food web prevents soil erosion by both wind and water by building structure. Please watch the animation on soil structure for more information. Another existential threat we are facing is ecosystem collapse. The UN has recently stated that insect populations have been decimated by around 25% each decade for the last 30 years. That means that there are 57% less insects today than there were in 1989. Bird populations have declined by 1/3 in the last 15 years in parts of Europe. So how does the soil food web help? Well, the UN has identified the use of pesticides as a major cause in the decline of insect populations. Please watch the animation on pests and diseases to find out how nature's operating system protects plants against attack, eliminating the need for pesticides. Another threat to life on Earth is climate change. Fortunately, the soil is capable of holding tremendous amounts of carbon in the bodies of microorganisms, and some mega-organisms too. The biggest living organism in the world is not a whale, it's a fungus found in Oregon that is the size of 1,665 football fields. It is between 2,000 and 8,000 years old, and it is made mostly of carbon. By restoring the soil food web, we could put a stop to climate change. Please watch the animation on soil carbon sequestration for more details. At the Soil Food Web School, we train people like you to help farmers transition away from using chemicals to farming in harmony with nature by restoring the soil food web. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com.
Okay, and then we'll tee up the next short video. Why is it not letting me? Hold on.
Why is it important to have well-structured soil? A well-structured soil will allow water to gradually flow through it. As the water passes down through the soil profile, it creates a vacuum, and so fresh air is drawn into the soil, thus creating aerobic or oxygen-rich conditions. This is crucially important, as the majority of disease-causing microbes cannot operate in oxygen-rich environments, and they are forced to shut down. Meanwhile, beneficial microorganisms thrive in oxygen-rich environments. Water droplets are held in the numerous cracks and crevices, and in organic matter for long periods of time, thus increasing drought resistance. Good structure allows plant roots to move effortlessly through the soil profile without having to work hard against compaction layers. In soils where good structure has not been built by beneficial microorganisms, compaction layers are easily formed by vehicles, by human and animal traffic, and where the soil surface is left bare by rainfall. Compaction layers force plant roots to grow sideways, limiting their access to nutrients and water. When plant roots break through compaction layers, they encounter anaerobic or low oxygen conditions. Those are occupied by anaerobic microorganisms, which produce highly acidic compounds. Roots cannot survive in such conditions where the pH can be lower than 4. When water flowing through a soil meets a compaction layer, it can't get through, and so, in heavy rain, this can result in a saturated layer of soil sitting on a hard compaction layer. If there is an incline, the topsoil can start to move, resulting in a landslide. This type of soil erosion is a big problem in many places around the world. So how is good structure built by the soil food web? Well, this depends on the type of soil we're dealing with. The terms sand, silt, and clay describe the size of the soil mineral particles. Sand particles are relatively big, and so are the spaces in between them. Water quickly finds its way through the gaps, and not very much water is retained, especially if the organic matter content is very low, as organic matter can absorb huge amounts of water. So sandy soils tend to be very dry and are prone to wind erosion, which is the process by which the topsoil is blown away and lost. Soil erosion is a serious environmental problem and poses an existential threat to humanity, as we only have around 60 years of topsoil left in the world, according to recent estimates. With the soil food web in place, the picture rapidly changes. Beneficial bacteria produce sticky compounds or glues, which make it easy for them to adhere to the surfaces of organic matter and sand particles. These particles then adhere to one another, forming microaggregates. Notice how as things clump together, small spaces are created around them. Fungi also produce some glues, and their long, narrow tube-like structures act like ropes, tying together the microaggregates to form macroaggregates. Now even larger spaces are formed in the soil structure. When microarthropods, earthworms, and insects burrow through the soil, they create even larger spaces like tunnels. All the while, the soil food web is increasing soil organic matter in the soil profile by decomposing the surface litter into humus and transporting it deeper and deeper into the soil. Soon you can dig down and discover layer after layer of dark chocolate brown soil, where there was once only lightly colored sand. The result is a structure that will hold water for several months after the rains have stopped, making it available to plants in times of drought. Roots are able to dig much deeper and to access more water and nutrients in parts of the soil that were never available to them before. In essence, the subsoil has now become topsoil. Dr. Ingham and her team have worked on landscapes such as pastures, turfed lawns, and golf courses, where the grass roots were only able to grow an inch or so into the soil because of the presence of compaction layers. In just a few short months after the soil food web is restored, those same roots are able to grow more than 3 feet deep, accessing more water and nutrients than ever before. In clay soils, the problems are a little different. Clay particles are often referred to as platelets, as they are kinda round and flat like the plates you have in your kitchen. Without a balanced soil food web, these platelets get stacked up on top of each other, forming very tightly compacted structures. Compaction layers can form very easily in clay soils. The solution to this problem is finding a way to get those clay particles to stop stacking. This can be achieved by a process called flocculation. Flocculation occurs when sufficient positively charged calcium ions are present on the surface of the platelets. This results in them repelling each other just like magnets do when their poles are aligned. The soil food web increases flocculation, and once this is achieved, structure can be built in just the same way as with sand particles. The result, once again, is a well-structured soil that enables plants to access more water and nutrients than ever before. For farmers, this means increased yields, cost savings due to reduced irrigation requirements, and even further cost savings as there is no longer any need to plow. Lower costs and increased yields result in greater profits. For the environment, there are a number of benefits. A well-structured soil that is home to the soil food web purifies water as it passes through the soil profile. This is because any contaminants in the water are seen by bacteria and fungi as nutrients, and are rapidly absorbed into their bodies as the water passes by. Soil erosion by wind and water are greatly mitigated, offering food security to future generations. And finally, water vapor is one of the most abundant greenhouse gases. By enabling more water to infiltrate the world's soils and to flow into aquifers, we may be able to contribute to the fight against climate change. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com.
All righty.
Okay, so you're all still muted and that's fine, but if you want to ask a question, then don't forget to unmute. I don't read lips very well. Just a few notes, and the first is, you may have heard the expression, a little learning is a dangerous thing, drink deep or drink not of the Pyrenean spring. And I have, right now, compared to the knowledge that's available, I have a little bit. But this is just fascinating me so much as to what is happening in this new field of study. Dr. Elaine Ingham, the author of the 2 videos we just saw, is arguably the world's foremost soil microbiologist. She's been at this now for about 45 years. When she was doing her PhD thesis and trying to structure that, she went to her professors and said, do you think I can make a living talking about the soil, studying the soil food web, etc.? And they said, lady, you're going to starve to death. But she is not starving to death. She's extremely busy with this and has done so much pioneering work in helping us to understand the importance of the soil food web, something we just knew absolutely nothing about. Relatively speaking, like there was just nothing. Her profs told her that the soil is just there, what's in it doesn't do anything, and it's just there to hold plants up. So hence we've been told that the soil has been depleted of its nutrients, and that's why we have nutrient poor food. That's not the case. Even desert sand has all the nutrients a plant needs, What we have lost is the biology in the soil. And once the biology is put back, you can grow in a gravel pit because the plants will build the structure. You saw that little animation on the aggregates or the micro aggregates becoming macro aggregates. And when you lift up, and I was going to bring in a plant, and I thought no, but when you pull a plant out of a little seedling, you bring it out of its pot, and I know in my case now, it's just a massive amount of soil sticking to those roots. That soil is glued there by the bacteria and the fungi. So that's how soil is actually built. And we can rebuild the soil that's gone into the ocean. We can rebuild it, and it's from the sand, silt, and clay particles, and ultimately from the bedrock where the soil is rebuilt. And that's where the plants get all of their nutrients, out of the sand, silt, and clay. We may go further into how that happens in a bit, but just to say that it's critical to have this soil food web in place. So what I've done sometime back in, a couple, 3 months ago, I enrolled in Dr. Elaine's soil food web school. And it has the first portion is 64 lectures, and you need 70% to pass. And then if you want to progress to the next level, because there are 3 levels here, if you want to progress to the next level, you need a 90% average. Right now I'm kicking in at about 96, so I'm okay so far. Then you can go on to study how to, and you become a certified consultant actually through the soil food web. And farmers all over the world are now hiring soil food web consultants to look at their soil, to see what's going on, and to reap the benefits. I think it's Gabe Brown, I think, is a huge rancher down in Midwest. He inherited a farm that was literally from his in-laws, and the farm was going bankrupt. He could not make money on it. So he said, either we give up the farm or we do something different. And he started to learn about the soil food web with Dr. Elaine. And now he is so profitable now, he's buying up his neighbors' farms. Because they're just, some don't want to believe it. They'll say, yes, it works for you, but it won't work for me, but they won't try it. Australia is probably leading the world in conversion to no-till farming and soil food, and understanding the soil food web and putting it all into play, into practice. What else would there? So I was saying I've enrolled in the soil food web. I'm partway through, so I know more than the average person knows about the soil food web, but I don't have all the answers yet. So if I don't know what you're asking, we'll find out, and I'll just tell you I don't know what we're asking, the answer to what you're asking. But I have a pretty decent grasp now on the overall food web as to how it's functioning and how I'm trying to make it work in my yard. I've been a no-till gardener for about 10 years now. I sold my tiller 10 years ago, and I've never tilled it since. A friend of mine out in Chemi has something, and maybe you've seen the video I posted using the penetrometer in my garden. And it's a steel stake about 2.5 feet long, something like that. And it has a pressure sensitive gauge on the top. At 150 PSI, if you push that into the soil, at 150 PSI, plants cannot go through there anymore. Plant roots can't get through, nor can water, and that's the compaction layer. Thanks to the way I've been gardening, not even knowing about the soil food web, just practicing no-till, I can push that down with almost 2 fingers, right down as deep as it'll go, and then I hit solid rock in my yard. So I can get down 18 to 24 inches any place, and the plants really like that. And so that it infiltrates water. I hardly ever have to water my garden because there's so much water being retained in it there. Okay, I think I can talk about other things after perhaps, but do you have any questions about what you've seen, why it's important, etc.?
I have a question actually. In the last video, the two examples they gave, one was talking about perhaps the soil in areas like golf courses. And they said after a few short months, when the soil structure's restored, how it improved. And then in the second example of sort of the clay substrate, it talked about the stacking and what you have to do to, I don't know, avoid that or break that apart.
Break it apart, yeah.
But I wasn't really sure for those two examples what the solution was to amend those problems. Like,
Right.
yeah.
I understand what you're asking, Barb. At least I think I do. The solution to getting the clay to separate, it's called flocculation,
Yes.
and to break up the compaction layer in the soils and allow it to percolate water and all of those things is the biology. When the bacteria go in, so you have, I say you, we, I'll use that interchangeably, okay? And I'm not pointing fingers at anybody when I say you. We have to stop fertilizing altogether with chemical fertilizers, because chemical fertilizers are salts, and salts bind with the water, deprive the plants of the water, and kill the I'll call it the microbiome. So all of soil life is killed by fertilizer. It's also killed by tilling. So you've seen the images of the fungi all mixed up like that in the soil. And they talked about the big one out in Oregon. Well, if you go in with any cut, with a hoe, with a shovel, tractor, with anything, and you start and you till that all up, you cut apart the fungi, and they're interconnected just like that. And one fungi for feeding one plant will take food over to another one. So we have to let the soil microbiome, just think of your own gut. You know, if we dumped our guts out and didn't have any microbiome somehow, or then you're not going to live. You know, you're going to die without a healthy microbiome.
Can I comment?
Barb, does that answer some of your question, that we need the biology in the soil and that's what does it?
Yes, thank you.
Stuart?
Yeah, I think Barb was maybe a little bit confused on how to break up the platelets in clay soils. And by the introduction of calcium and some of the other light minerals, that will induce oxygen to go into the soil and break up the clay. So you're forming calcium oxide, magnesium oxide, those kinds of things, and that will allow oxygen.
Stuart, we're having real trouble understanding you. Perhaps speak a little louder and closer to your mic. We'll try that.
Yeah, okay, is that better?
That's much better.
Okay, yeah, what I was going to comment on is that I think Barb was looking at how to break up clay soils naturally. And the introduction, I think in your video there, it showed that the introduction of calcium and magnesium, some of the lighter metals, attract oxygen into the soil. And that creates spaces for the microbiome to multiply and to spread. And that's a fairly natural thing. Like, I mean, remember back in the day that we used to be able to get carbonatite, which was calcium and magnesium and those kinds of minerals that actually, if you like, aerate the soil to let the microbiome grow. So I hope that's a more technical explanation of it, but that's what I found here, and it's sort of amazing.
The calcium is apparently a temporary fix, but the permanent fix is for the biology to go into the sand, silt, clay particles, extract the calcium out of it, and then build the soil structure. When it actually builds the structure, one of the lectures I was watching recently said that calcium lime is calcium rich, and the standard practice, and the one that I learned and that we all learned pretty much, is to use calcium when the soil has a low pH. You're going to raise your pH with it. Apparently, it only lasts for about 2 weeks, and the soil's right back to where it started again if you don't change the biology.
Yeah. Okay. So again, you're talking about calcium oxide versus anhydrous calcium because it doesn't have the oxygen molecule attached to it. So what that does when you apply that, that brings the oxygen into the soil, which allows airspace for the microbiome to thrive. And that's part of the regeneration process. As far as how long it works, I'm not sure, but it seems to have improved our soil conditions here on the farm quite a bit. So anyway,
Yeah. Okay. And I will accede to your knowledge, because you were a chemist by profession, and the chemistry is probably the hardest thing that I have to keep grasping, how one chemical changes to another when it binds with oxygen and all the rest of it.
yeah, yeah, for sure.
Yeah.
No, I spent 32 years in chemical engineering research, and so I know my chemistry like down pat.
Okay.
I'll leave it there.
Any other questions?
I have a question. So I'm really interested in making Twin Forks no dig gardening, free tilling. So the whole issue of weeds and how you deal with that, and stuff that is, the difference of dealing with raised garden beds versus in-ground gardens. So we have garden beds that one of them, for example, is infested by some kind of weird weed, looks like a horse's tail almost, but
Horsetail.
at any rate, it keeps coming up. So you can yank it out really easily, but that's disturbing everything, right? So just wanting, like, realistically, if we wanted to implement this in our community gardens, what would that look like?
So what you're dealing with there in the one specific weed, it looks like a horsetail because that's what it's called, horsetail. Plants come in a succession, and they didn't have time, obviously, in the little videos to address everything, but in the very poorest of soils, you'll get the really hard weeds, hard scrabble weeds, really tough grasses. But as the biology increases, and particularly the bacteria or the fungi to the bacterial ratio, you want to get the more fungi you encourage in your garden, the less weeds you're going to have. If you look in and the top in this weed progression, or in the soil or plant succession, I'm sorry, you go from grasses up through all different kinds of shrubs and stuff like that, and to the kind of forest we have around here, to the kind of forest we used to have, the massive pine forests. That's the top of the food chain as far as vegetative life is concerned. There's almost no weeds grow under those forests, in the Douglas fir forests, in those things, because the fungal ratio, the fungal count is so high compared to the bacteria. So when you have a bacteria-rich soil with no fungi, you're going to get a lot of weeds. I don't know exactly where horsetail fits, but I would think it's on a lower succession. It's a really old plant form, I think, from what I've read. So it's going to respond to a higher bacterial ratio. So every time you till your garden, you're increasing the bacteria, reducing the fungi. Now, I'm not saying you're ever going to get rid of that horsetail, but horsetail has some really good nutrient profiles in it. And if I had a whole garden full of horsetail, I would be working on increasing the fungal level in there. And the fungal level is supported by the fungal foods, where you're using wood-rich compost, leaves, that kind of thing. So if your compost has a lot of carbon in it, it's going to be more food for the fungi as opposed to for the bacteria. And you want to, so if you're going to make your compost and have it all kitchen scraps and lots of bread and flour and that end of it, that's party food for bacteria. And they're going to party in there and they're going to proliferate. So as you're trying to increase the fungal level, horsetail only grows about, 8, 10 inches high normally, I think, unless you're really big stuff in the tropics. They have big ones. But then plant right through it. Just let's say you're going to grow tomatoes. Don't worry about the horsetail. The more diversity you have in your garden bed, the stronger the bacterial and fungal community is, and the more diverse gives you a lot more food for the tomato plant. My tomato bed, and I just posted a picture in the Sudbury Gardening Bee, I planted the tomatoes down the middle in a 4-foot wide bed. Next to that is going, on each side is going a row of leeks, and then there's going to be about an 8-inch wide carrot strip down each side. And maybe I might have room to put a few beets in there, I don't know. But it's going to be really jammed in together, and it will become very productive. When you're putting, you don't need to have a lot of space. You don't need 2 feet around the base of a tomato plant. So you plant, you have your weeds, if it's dandelions or horsetail. Each of those is doing its own thing in the soil. So the dandelions have that long taproot that goes down. They're bringing up minerals and nutrients from deep that your tomato can't reach. And then the fungi and the bacteria transfer those minerals to the tomato plant. So this is why we don't have a shortage of minerals. We have a shortage of bacteria in the soil, or microbiology in the soil. Did that help, Rachel?
Yeah, so I mean, I'm considering, I did the go around my neighborhood and pick up a whole bunch of bags of leaves. And so they're sitting right now at the park in the great big white bags that we had Meeker's Mix delivered in. So, I'm going to be laying that on top for mulch. And so I like the idea. Should we be like at ground level snipping off this stuff as it comes up?
You're not going to win that game. But speaking of snipping off, I'll go back to my tomato plants. Even last year when I was starting to learn this stuff, I didn't pull my tomato plants. I cut them off at ground level. Because when you pull it, all of the life that's attached to the roots of the tomato plant, you're yanking it out and killing it. And now you're leaving no living root in the soil. And that's key to this soil food web success, is that for as much as you have a growing season, for ours, it's, we can have a living root in the soil 8 months of the year. If you count things that come up in the spring really early, and a fall rye on your, my garlic bed is going to get a fall rye planted on it this year, and it'll stay there right until the absolute hard frost kills it in late October. A living root in the soil will keep the biology alive. If the biology has to go dormant, then it has to start up and rebuild itself again the next year. So even I am pretty convinced, and I just put this out to my own private forum, that for the Soil Food Web, does garlic being in the ground over winter and it's alive and a living root, I'm pretty sure things like that, the bulbs, the perennial bulbs and that, they constitute a living root in the soil over winter. So there's something for the biology to keep living on. And I'm sure it morphs, it changes because different biology is active at different pH levels and at different temperatures. So you want to try and keep, and what you said is snip the plant off, snip your harvest plants off at the soil level and just leave them, because when they decay, they let the water, their channels as they decay for the bugs and the critters to move through and for the water and the air to move through. So if you're going to put, and the other thing that Dr. Elaine teaches is don't rotate your crops. You don't have to, even in a small garden, trying to rotate a crop so that your garlic never comes back to the same place for 7 years, it's impossible for me, even with 1,500 square feet. I have 500 head of garlic out there and I just can't rotate them like that. And that's a whole other field of discussion, but she says, no, you don't have to take and rotate your crops. So my potatoes stay in the same spot. The biology looks after whatever is needed for each crop, and each plant type goes and harvests its own nutrients from the sand, silt, and clay. Does that help?
Yes.
Oh, one more thing. When you before you put your leaves on, throw them all down on the ground and run over them with a lawnmower. Make them smaller. Your next point you wanted to?
I was just saying, like, we've got about 1 minute left. I don't know if anybody has a last question. I think this is just the start of the discussion about how, from a community garden perspective, we can start thinking about, do we need to fertilize? How do we do things differently so that we don't have to spend all of this time working at things, right? It just takes care of itself naturally.
So
anybody else got a question?
And you can come back to me, I'm not hard to find on Facebook and such. Linda, you'll have to unmute yourself. Unmute
You're
yourself,
on mute, Linda.
So while she's unmuting herself, Rochelle is going to put up some other links and resources that I suggested, and they are really, really good. There's so much out there. Google Dr. Elaine Ingham, and it's easy to find through the Soil Food Web School. She's amazing, and it's a rabbit hole. When you go down it, you're never coming back up. Linda, yeah.
Those links are actually in the chat, and I'll include them in the notes.
Good, thank you.
Okay, I have a leaf shredder if anybody wants to borrow it.
Oh, cool.
It's a stand-up one.
Lawnmower is probably my experience, a lawnmower is a lot quicker than my shredder.
This concludes our May meeting discussion. Thank you for watching.